Hello, everyone. Welcome to Mathematics with Teacher Abbas, and we are in speed. So, this is a new topic, and we're going to take the introductory part of it, which will cover the definition, the formulas, and the rules that will guide us when dealing with speed, and also the key relationships that we need when dealing with speed. Right. So, let's look at it. But remember, in our last class, we just finished time, which is going to be an essential topic under speed. So make sure you are fully acquainted with time. So let's see. Speed can be defined as the rate at which an object covers distance. At the rate can be defined as the rate at which an object covers distance. So the rate there is telling us how fast or how slow an object covers distance, which is like telling us the time taken, the time taken for an object to cover distance, the time taken for an object to cover distance, a particular distance. So the time taken will determine if it is fast or slow. So the time taken will tell us how fast it is or how slow it is. For example, if you have one child going to school, maybe trekking to school, and the child takes maybe 20 minutes, and then you have another child trekking to school, and that child takes 30 minutes. So the time they tells us is the same distance. Let's say they are living from the same house, and then they are trekking the same distance down to the school. So it tells you that one child went at a high speed than the other child, at an higher speed than the other child. So take note of that. So a fast moving object is said to have a very high speed and covers a relatively large distance in a given amount of time, while a slow moving object covers a relatively small distance in the same amount of time. So speed is measured using a speedometer. We measure speed using a speedometer. So let's say speed equals to distance. Let's go to the formula now. Speed equal to distance over time. Speed equals to distance over time. And distance equal to speed times time. Distance equal to speed times time. Time equals to distance over speed. Distance over speed. And then we have what we'll be looking at as average speed. Average speed equal to total distance divided by total time. Total distance divided by total time. So when we start applying the formulas, you see how we use it. So, but take note of the formulas. It's very necessary. Speed is distance divided by time. Distance equals to speed times time, and time equal to distance divided by speed. Right, so let's look at unit of speed, distance, and time. Unit of speed, distance, and time. Now the unit must correspond. The unit must correspond. Now this is kilometer per hour. Kilometer per hour. Kilometer per hour. It can be written as this: kilometer per hour, or kilometer then h raised to power minus 1. It can be written as this or as this. The two are correct. So kilometer per hour. Now, what does this tell us? This tells us that the distance is in kilometer. That pay you are seeing there means divided. That's why speed is distance divided by time. So it's like kilometer divided by the time, which is hour. So kilometer divided by hour. That's why you see kilometer pay. That pay shows that is division, so per hour. All right. So per um, kilometer per hour there means that distance is kilometer and time is in what? Hours. And then meter per second. Remember, these are different units. Um, Kilometer is a unit of length, meter is a unit of length, centimeter is also a unit of length. So we are just looking at the different units you can see that you likely come across. Kilometer per hour and meter per second are really common. All right, so meter per second, that means distance is meter and then our time is seconds. Then we have meter per minute. That means meter is for distance, and then our time is minute. We have centimeter per second. distance is in centimeters, and then time is in seconds. So let's see, in solving problems involving speed, the distance is usually the length of the journey. Distance, which is the length of the journey, is divided by the time. Which time? Now look at the time we are looking at, because we just finished time and then we talked about departure time, destination time, and time spent. So which of the time are we looking at? The time we are looking at is the time spent. Time spent, not departure time, not destination time. We are looking at time spent during the journey. So the unit of speed must correspond to the unit of distance and time. Take note of this. The unit of speed must correspond to the unit of distance and speed for of distance and time, sorry. So for example, if speed is in kilometer per hour, that means the distance must be in kilometer and the time must be in hours. Please take note of that. All right, so let's see. Important relationships you may likely see in speed is that 1 kilometer is equal to 1,000 meters, 1 meter equal to 100 centimeters, 1 hour is equal to 60 minutes, 1 minute equals to 60 seconds, and 1 hour is equal to. All right. So these are the basic units that you must take note of. These are the basic units you must take note of. So this is all we'll be having for this lesson. It's just an introductory class. We've talked about definition of speed. We've talked about the formulas we'll be using using under this topic. We've talked about the unit of speed, and then key things to take note of, and then the important relationship you will likely be using as you are solving questions involving speed. All right, so that will be all we'll be taking for this lesson. So in our next class, we are going to continue with the solvings. Then we'll see what to do. So thank you for joining. Please do well to like, subscribe, and also share to others. I'll see you in the next class.